Alrighty, my friends, welcome to the last and final installment of our video series for this week. So we've talked about what things are limiting factors for primary productivity, or requirements, I guess I should say. So we know that sunlight is a really big thing here, as well as nutrients, right? We kind of need both in order for things to really get crack-a-lackin' in terms of phytoplankton and plankton blooms. So now I want to talk about kind of the three sections of our planet. If we were to cut the top half of the planet into three areas, we would have the polar seas, the temperate seas, which is where we're at, and the equatorial tropical seas. So we really have to remember that we're talking about the open ocean here. We're not talking in the coastal waters. We kind of already covered that in particular. So now we're thinking open ocean. And I want you to consider, which ocean do you think would be the most productive? Polar, temperate, tropical. Where do you think would see the most production? And again, plant life, open ocean, not near the coastal areas. So it turns out that the polar areas are actually the most productive, which is pretty crazy. So what we're looking at here is months on the x-axis and phytoplankton biomass on the y-axis. And we can see here, with the bottom line being tropical, this sort of green curve being north temperate, and this kind of light blue curve being the north polar, we can see that there is a much, much, much greater response in the phytoplankton biomass in the summertime for the north polar area. And it's really, really fascinating, I think, because you would think, oh my gosh, like tropical seas, equatorial seas, and you think like coral reefs, you think that's just my platonic ideal of a tropical space is, where humans still reside, which means we're not in the open ocean, right? So again, break that connotation. We're traveling out to the open ocean where no humans live. So in this case, we can see that the North Polar, if we were to take like the whole average or the whole area underneath the curve, yes, North Temperate would be the most abundant, but North Polar has the greatest spike. And there's a big, big, big reason for all of this. So what happens is that there is a development of a thermocline and a pycnocline, by the way. If you remember what thermocline is, it's a sharp change in temperature in a short space. And the pycnocline is the change in density as well. So what happens is that acts as a very, very, very efficient lid or doorway, which doesn't allow for any sort of mixing or nutrients from the deep ocean up to the surface. So that's, in a sense, that's like really the biggest limiting factor here in this case, because if you have that really intense thermocline, you're not going to allow for any mixing. Think of like oil and water, right? We've probably all done that experiment where like you have a beaker and you have it filled with different liquids, right? And how oil is less dense than water. And even if you try to mix it a little bit, it will eventually separate back out again. So similar sort of idea, but with the ocean water. So that really keeps the nutrients down in the deeper oceans and doesn't allow for anything else to happen in the surface waters. All other things considered basically the same. So if we were to look at a temperature profile of the polar oceans, we have temperature on the x-axis and depth on our y-axis in terms of kilometers. We see that it's isothermal, right? There's no thermocline, so there's constant mixing in the polar oceans in the vertical. But there is a huge limiting factor of productivity for the polar oceans. What could that be? It's that big shiny thing in the sky, the sun, right? So the polar areas are tilted away from the sun in their respective winter times, and so there's no sunlight. And even when the sun does come up and arise, the angle is really steep, so you're not going to have as much depth in terms of phytoplankton blooms, but there can be a really strong signal in the polar areas. That's why whales travel north in the winter to go eat. We eat up there, right? So humpback whales will start down in Cabo in the summertime, where they take a vacation and mate and breed, and then they will migrate, oftentimes will migrate up to the polar oceans in order to feed. Because in the summertime, because the sun comes out and it comes out to play, and then plankton are like, oh my god, I miss you so much, and then we have a big boost there. For the temperate oceans, there's this sun angle situation and seasonal thermocline. If we remember back when we talked about vertical ocean structure, we saw that the mid-latitude areas have that seasonal thermocline, right? So in the wintertime, there's the least amount of light, so not much of a thermocline. However, there's not a whole big amount of sun. Like the sun angle is kind of like meh. Whereas in the springtime, the sun angle is getting better. So because there's nutrients kind of in the water already from that initial lack of thermocline, then it's like, all right, sweet. Now all things are at play here. Phytoplankton, bang, boom, shebang-a-boo, and then zooplankton will follow shortly after. Whereas in the summertime, the temperate oceans have too much of the direct angle of the sun, so the thermocline is really strong and nutrients eventually gets depleted. And then in the fall, the sun angle starts to dissipate a little bit, the thermocline starts to chill out, and more nutrients can then come back into the area. So for temperate oceans, winter and summer, least productive. Spring and fall, most productive for both phytoplankton and zooplankton. So this is looking at a map, a graph of lots of different things. I'll walk us through it here in just a second. But it's basically all of those same ideas from the previous slide, just kind of concentrated into a different sort of graph here. So the orange light the orange line is looking at sunlight. The purple line is looking at nutrients. The green line is phytoplankton bloom, and the light blue line is zooplankton. So some things to point out here, right? And this is again in the middle latitudes, the temperate oceans. So where we have peak sunlight is not where we see our peak blooms, right? In the summertime, not peak blooms here. In the wintertime, and that's when nutrients is really poor, right? Nutrients gets all used up. But in the wintertime, the nutrients is at its high, but the sunlight is not that great. But finally, where these things kind of start to kind of intersect here, that's when we start to see our phytoplankton and our zooplankton blooms respectively. There is a reason, by the way, why we see the phytoplankton bloom ahead of the zooplankton bloom. Zooplankton gotta eat, and they oftentimes eat phytoplankton or each other. So that's kind of the big thing there. Spring, fall, is where our blooms tend to peak. Winter, summer, not so much in the temperate oceans because of either lack of sunlight or lack of nutrients. And here is another, I know there's a lot of panels going on here and I'll try to kind of walk us through it, but it's basically showing, again, all of that same information, but just in a different sort of way. So the top panel, by the way, goes mid-latitudes on the left, tropical in the middle, high on the right. I don't know who freaking designs these books and why they don't put tropical, middle, high, but here we are. So the top panel is looking at the daily light input, so how much light is coming in. The nutrients levels of the second panel, the phytoplankton and zooplankton abundance in the third, surface water temperature in the fourth, the vertical profile temperature in the fifth, and then the photic zone and mixed layer depth on the bottom. So again, the big things to take away here are that tropical latitudes don't have any nutrients and a whole heck of a lot of sun, thus a very strong thermocline. So because of that, they don't really see a huge abundance in plankton and zooplankton. Whereas in mid-latitudes, we have our peak of sun in the middle of the year, but no nutrients. So in the wintertime, more nutrients, but less sun. So kind of where these two barriers kind of come together is where we can finally see our blooms. And similarly, but for the opposite, for high latitudes, most abundant sun in the summertime. And that's when we see our blooms here. And there's really just not a whole lot of a thermocline really at all. So the nutrients kind of dips down a little bit once it's starting to be used up by the plankton. So just to review, this to really kind of hone in on this idea, really hammer in this idea of what areas are most productive. Again, this is looking at chlorophyll concentrations. In the water, the red color indicates higher chlorophyll concentrations. The cool colors indicate lower chlorophyll concentrations. And we can see basically huge holes or huge deserts in the open oceans, especially in the tropical areas. So we can see kind of like this little sort of tongue of nutrients kind of coming around at the equator. Just remember, it's because there's a whole heck of a lot of transport going on there, right? So we have all of this nutrients coming up off the coast of South America. And then with our water movement, it's able to transport this way. And we also have equatorial upwelling as well. So kind of a combination thereof where we have those areas of convergence and divergence in the water. And then our polar regions are really, really teeming with life here, especially in the open ocean sort of area, and even over here by Alaska. And it's kind of hard to see because that area is kind of cut off a little bit. And the reason, by the way, that Antarctica seems to be pretty barren, even though they're like, dude, polar areas, how is that not teeming with life? There's a lot of ice kind of on this whole sort of situation. So it's a big old ice cap, but there is sea ice here as well, and that can probably limit any sort of plankton activity. So this slide here is a very, very important slide. This will be a short answer question on your final exam worth 12 points, which seems like a lot, but there's a lot going on here, right? So I will want you to describe the areas, the seas between the polar, temperate, and equatorial / tropical seas. Which season is most productive, which season is least productive, and why. So you gotta tell me the why behind all of this stuff. All right. So that, in a sense, finishes up our section on productivity. So when we return, we'll finally start talking in far more detail about the various creatures in the ocean. Yeah, slide 22 of lecture 28. Short answer question on your final exam. No question about that. Okay. Thank you so much for your time and attention and for watching. If you have any questions or need clarification on anything, please do not hesitate to reach out. And I'll see y'all on the flippy floppy. All right. Thank you. Bye.